Hi, Math 8. It's time for assignment number 12. And this assignment is on volume. And it is not, of course, the volume on your. Wow, that's one old iPod right there. But that's not the volume that how loud something is. That's not what we're talking about, right? What we're talking about with volume is the amount of space in a three-dimensional solid. So, for example, think of any shape that has three dimensions. You can see a whole bunch of three-dimensional shapes down here. So, for example, I don't know, consider this one right here. If you're looking at the volume, what you'd be thinking about is if you poured water or liquid into this prism, this rectangular prism, how much water would it hold, right? Or how much space does it take up in the world? Uh, yeah, if I was to fill this cube with paint, how much paint could fit inside of the cube? That's what we're talking about when we're talking about volume. How much space is inside a three-dimensional solid? All the things we're going to look at today are prisms. And what prisms are three-dimensional solids with two congruent parallel faces. Those are called the bases. Okay, so all these shapes we're doing today should have two faces. Those are like two sides. But when we're talking about three-dimensional objects, the proper name for like this square right here, you don't call that a side, you call that a face. This is a face. This is a face up here. This is a face on the side. There's a face at the back. There's a face at the bottom. There's a face on the left, right? There's 6 faces total. So all the shapes we do today are going to have two bases, the parallel faces. We're actually going to do 3 different types of shapes today. We're going to do rectangular prisms, we're going to do triangular prisms, and we're going to do circular prisms, which are also called cylinders. So look, the parts that are parallel here, the base, are the circles. The circles are parallel with one another. Those are the bases. In the triangular prism, the parts that are parallel to each other are the triangles. This triangle and the triangle over here are parallel to each other. Those are the bases. In this triangle here, or this prism, sorry, the triangle here on the end is parallel to the triangle on the other end. The other sides are rectangles, and those aren't parallel to each other. So, yeah. Okay, so that's what we mean by the parallel faces, which are called the bases. When you find volume, the answers are in cubic units. Remember when we did area, they were centimeters squared and meters squared. Now we're going to do millimeters cubed or centimeters cubed or meters cubed. And hey, these are three-dimensional shapes, so it's a 3 there as well. It's not too bad to remember. Okay, here's the big formula. It's kind of like a master formula that we can then use to find different formulas for the 3 different shapes. The master formula is that the volume of one of these shapes is equal to the area of the base times the height of the prism. And then if you use that, you can actually get a bunch of different formulas for the different shapes. All right, let's just start doing this. You've probably done this sort of thing before anyway, so let's just jump right in. So the first thing we have here is actually a cube, right? If you take a look, I guess I'll do the dotted lines. It's kind of hard to do, but okay, like that. All the these are called edges. All the edges are the same length. 3, do you know what those 2 tick marks mean? Those mean inches. 3 inches, 3 inches, 3 inches. They're all 3 inches. So this is a cube, actually. It's also called a square prism, but we'll call it a cube. So to get the volume, you have to find the area of the base. Well, you could actually consider any of the faces a base. I'll consider this the base. I'll think about this as being the base. So how do we get the area of that? You multiply length times width. Or if you want, that's actually a square. You could also think of it as side squared. I'll do length and width though. So the volume is equal to the area of the base, which is length times width. And then you want to multiply by the height of the prism. Well, the height would be this amount right here. That's your height. So you actually end up with length times width times height. And that's what's always going to work for these rectangular prisms. That's your formula for rectangular prisms, is length times width times height. Whether it's a square prism or a rectangular prism, you can always use this formula. Okay, now it actually turns out for a square one, there's a faster way you could do it. What do you know about the length, the width, and the height in a square, in a cube? They're all the same. So if you called, for example, instead of calling it length and width and height, if you called it side, S, you'd have S times S times S, because they're all the same. So you'd get that the volume is equal to S times S times S, which is S cubed. You could also use that as your formula just for the square one if you want. Anyway, I'm betting almost none of you will do that. You'll all use length times width times height. So why don't I just leave that right in here? So what you're going to do is go length times width times height. The length is 3, the width is 3, the height is 3. 3 times 3 is 9, times another 3 is 27. And as I said, those tick marks are inches. So it's 27 inches cubed. Remember, all our units, as I wrote up here, all the units are cubed when you do volume questions. So that is your first answer right there. Okay, the second one. We want to get the area of the base again. So we have a rectangular prism this time. We want to get the area of the base. Which one's the base this time? Again, when you're doing these rectangular ones, it doesn't really matter which one you call the base. I'll call this bottom one down here the base. So you need the dimensions of that face down there. What are the dimensions? We need this one, which we know, it says right there, it's 7. And we want to multiply by this one here. That's not a square, believe it or not. Do you see what length this is here? This length is the same as this length. It's also the same as this length here. And it's also the same as this length here. Oh, look at that. It's 4. All those ones in red are all 4. So to get the area of the base, which is a rectangle, this down here is a rectangle, you have to go length, which is 7, times width, which is 4. So you go 7 times 4. That gives you the area of down here. Then you want to know how many, it's kind of like how many of those rectangles would fit here. You'd have another one, another one, another one. So you need to multiply by the height of this thing because it'll tell you how many slices you can do. Well, the height is right here, 10. So we've got the area of the base, right? Always using this master formula. Area of the base, and then I'm going to multiply it by the height, which is 10. Again, if you don't like this formula here, the master formula, you could also use this new formula we figured out here for rectangular prisms, length times width times height. And just by looking at this thing right away, you could tell, oh, length, width, height, the 3 dimensions, multiply all 3 dimensions together. It's as simple as that when you have a rectangular prism. So 7 times 4 is 28, times 10 is 280. It's centimeters, so it'll be centimeters cubed. So those are the rectangular ones. Just multiply the 3 dimensions together and you're good. All right, the triangular prism. So what's the base? Do you remember? The base are the faces that are parallel to each other. The bases are this triangle and this triangle. Those are parallel to one another. They're the same distance apart at all times. So what we need to do, the master formula tells us, to get the volume, we have to get the area of the triangle, of the base, right? So you need to get the area of the triangle and then multiply it by the height. Well, how do you get the area of a triangle? The area of a triangle is base times height divided by 2. And then once we've done that, we want to multiply by height. Wait a minute, we already have height here. This is what's really confusing about these questions. People often get confused about it. This height here is the height of the triangle. This height here is the height of the entire prism. Okay, so let's just focus in on the triangle, right? B times H divided by 2, this right here, we're just worried about this triangle right here. So what's the base of that triangle? The base is 4. We're going to multiply by the height of that triangle, just of that triangle. Just look at this highlighted triangle. What's the height? 3. So we got 4 times 3 divided by 2. Now, we want to multiply by the height of this entire prism. So, for example, if this is one triangle here, how many slices of triangle do we have? How far up does it go? It goes up 11. That's the height. If it was sitting, if we prop this so this was the bottom right here, I think it's what confuses people. Base often means bottom, but it's not necessarily the case when you're doing these questions. However, if this was the bottom, if it was sitting on this triangle, what would the height be? The height would be this. This is your height right there. I know it's confusing. You've got the height of the triangle and you've got the height of the prism. So this would be times 11. Now you're good to go. 4 times 3 is 12, times 2 is 6, and if you multiply that by 11, you get 66. 66 centimeters cubed. Okay, let's do another one of these because they are tricky, these triangular ones. So again, we want to figure out what the base is first. The base is not the rectangle. This is not the base down here. I know it's sitting on that, but that is not the base. Turns out again that the bases are those triangles again, this one and this one. So the first thing we have to do is get the area of that triangle. How do we do that? Base times height divided by 2. Then we want to multiply by the height of the entire prism, not the height of the triangle, that's this height here, right? But the height of the entire prism. Okay, just look at this triangle right here. What is the base of that triangle? The base is 10. So we've got 10 times, what's the height of that triangle? From the highest point straight down is 15. 10 times 15 divided by 2 times, now what's the height of the prism? If this thing was sitting on the highlighted side, what would the height be? It'd be the 20. Or if you want, if this was one triangle, how many of those triangles could you put next to each other, next to each other, next to each other? You'd have this many right here, the 20 centimeters worth of them. So your height of the entire prism is 20. We got 10 times 15, which is 150, divided by 2 is 75, and then we multiply that by 20, and you'll get 1,500, and it's centimeters cubed. All right, we got one last shape to go. It is a cylinder. So we can use the same master formula. Remember, volume equals area of base times height of prism. So the base are the two faces that are parallel to each other. The faces that are parallel to each other are the circles. This circle here and this circle here. So we want to get the area of the circle. Well, what's the formula for area of a circle? Do you remember? It's pi r squared. And then we want to multiply by the height of the prism. So this is the formula you'll see. We got it by using the master formula. But for all cylinders, the formula for volume of a cylinder is pi r squared h. Okay? Where h is the height of the prism and r is the radius. So here we go. Volume equals pi radius. What's the radius of the circle? What's the radius of the base? The radius is 25. So we got pi 25 squared, and then we've got h, which is the height of the prism. Well, that's this distance right here, so it's 40. So we've got to go pi times 25 squared times 40. So there's two ways you could do this. One way is you could do your 25 squared. You should do that first actually, and get 625 times 40, and we still have our pi. So that gives you 25,000 pi. That's a totally acceptable answer. It's actually the most exact answer. Or you can actually multiply by pi. Pi button would be great for that. And you'll get 539 point, I'll do one decimal place, 8. And we're talking about inches, so it'd be inches cubed. And there's your answer. Okay, so for cylinders, this formula will always work. All right, one last point. I forgot to put numbers on this. Let's say that you were told that the area of the base here, you're told that the area is 16 meters squared, and then you're told that this dimension here is 10 meters, and you wanted to get the volume of this. Okay, remember, the volume equals the area of the base times the height of the whole prism. So they give questions like this a lot in your homework. Looks all really difficult. Whoa, look at this. It's a hexagonal prism. So hard. But what we need to do is find the area of the base, and they give us the area of the base. The area of the base is 16. So for this whole area of the base, you can just put 16. There's no calculations to do at all. And the height is, well, here's the height right here, 10. Oh, I'm done. 16 times 10 is 160. And we're talking about meters, so it'd be meters cubed. So there are some questions like that where they give you the whole area of the base, and you just have to multiply that amount by the height. All right, it's pretty fast. I think what I might do is give you a shot at it today. Let me know. Please text me, email me. Let me know how it's going, if it's really hard or whatever. And then next day I'll probably just do a tiny bit more of almost the exact same thing. I have a suspicion this has probably been a little too much too fast. So I'll probably just add a tiny bit next time, a few more questions, and we'll do this over 2 lessons. But who knows? Maybe you guys will get it. I know you're bright and doing an awesome job, and keep it up. Those people who are doing all your homework, I really appreciate it. So we're up to assignment 12. It's due on Monday, May 25th at 3 p.m. And here's the assignment. It's in your workbook. It's pages 182 to 183. You're going to do numbers 1 to 12. It's finding the volume of rectangular prisms, of cylinders, and of triangular prisms. So I've done each of the types in this video. Hopefully that'll help you to get that done. If you're having troubles, let me know. I'm here to help. Take care, people. Maybe I'm going to see you in June. Would be pretty fun to see ya. Take care. Bye.